Hey guys, welcome to Bio112 Online. What we want to do today is go over the most recent group work and homework assignments so that you guys have the answer and can compare it to the answers that we have. For group work number 5, when we look at the initial question, it says we have two students, Bernadette and Gertrude, and both of those students are feeling a little under the weather. They go to the health center and get a blood test to take a look at their thyroid glands. In that test, when we come along to 1A, it says describe the data comparing the levels of TSH and T3 in Bernadette to the levels of a normal patient. And for patient number 1, Bernadette, you look down and it says that she has about 1 microgram per liter of TSH, or thyroid stimulating hormone, compared to a normal of 7. So that seems to be a bit low. Looking over at T3, we then see that she has 0 T3 compared to 200 nanograms per liter in a normal patient. So then, based on your knowledge of hormone cascades, predict which gland is not functioning correctly. So looking at that, yes, there's a problem with the thyroid gland not producing enough T3, but that could stem back to that problem of lowered TSH. So therefore, our target gland, moving back up, would be the anterior pituitary gland. If the anterior pituitary gland were not producing enough thyroid stimulating hormone, then the thyroid gland would not be producing enough T3. Okay, that makes sense. So that takes us to 1C, which says propose a cellular or molecular defect in Bernadette that explains how this defect would result in the levels of TSH and T3 observed in figures 1 and 2. And you say to yourself, okay, well, assuming that thyroidotropin releasing hormone was at normal levels, in that case, you might come along and say, well, then the problem might be with something like the receptor. In that case, if the anterior pituitary is not receiving the signal from TRH to release TSH, then it wouldn't release TSH, therefore you wouldn't have as much T3 being produced. Option number 2 would be that there's some type of problem with the anterior pituitary where it's gaining the signal but is unable to produce that TSH. In either case, you would not be able to produce a TSH, and therefore you would not be able to produce as much T3. When we come to 1D, we say propose a possible treatment for Bernadette that would restore her TSH level and T3 levels to normal. Well, okay, well in that case you could give some type of supplement for TSH. A more medically relevant and less expensive way of doing this would simply be to give a supplement of T3 and basically treat the symptom, which is commonly done. We come to patient number 2 for Gertrude. For Gertrude, she has a slightly different problem. When you look at her TSH levels, you'll see that they're actually higher than normal. They're up at around 10 micrograms TSH per liter compared to 7 for normal. When we then compare what's going on in T3, we again, though, see that there's no T3 or very little T3 being produced relative to the 200 nanograms per liter seen in the normal patient. So based on your knowledge of hormone cascades, predict which gland is not functioning correctly. So you're looking at these, okay, one's producing too much, one's producing too little. What could be going on here is that the thyroid gland itself is not producing enough T3. That would give the issue with the T3 low levels, but it would also then explain what's going on with the thyroid stimulating hormones because you would not see that normal feedback going from the T3 to inhibit further release of thyroid stimulating hormone. Without that negative feedback, the thyroid stimulating hormone concentration would be much higher. So in that case, we're zeroing in on the thyroid gland as our problem. When we come to C, propose a cellular mechanism or defect in Gertrude and explain how this defect would result in levels of TSH and T3 observed in figures 1 and 2. And so in this case, you take a look and you say, okay, what could be going on? Well, you have a couple different issues. One of which is you could run low on iodine. If Gertrude is eating a low iodine diet, then she may not have sufficient iodine to make T3. If that were the case, then she couldn't make T3 no matter how hard her thyroid tried, leading to something like a goiter. In that case, you would fit the data. Option 2, though, would be that there's some type of damage to the tissue in the thyroid gland. If there's some type of damage to the tissue in the thyroid gland, then again, she might run into a problem where she was unable to regulate T3 or produce T3, and therefore, you would again see that same general pattern. So depending on which of those two options you chose, you could say that the possible treatment was for Gertrude was that she didn't have enough iodine, and therefore the treatment would be eat more iodine, eat more fish, use iodized salt, etc. If you said instead that there was some type of problem with the tissue of the thyroid gland, it was damaged, it had some type of defect to it, in that case, you might say, okay, well, the solution again would be to treat with T3 as a supplement. And that takes us through group work number 5. Next, we wanted to go through homework number 3. Recall that this is Jarno and Leslie, a couple who is trying to have kids and has run into a little bit of difficulty. First, describe the data showing Gennaro's hormone and sperm count levels compared to men of his normal age. Taking a look first at the data for Gennaro, you would see that his GnRH, gonadotropin-releasing hormone, and luteinizing hormone are much higher than normal, but that his testosterone and sperm count are lower than normal. When you ask yourself, well, what could be going on here? Describe a cellular or molecular mechanism that would explain infertility. You could go with one of two problems. You could first say it could be the Leydig cells. If the Leydig cells are not receiving the signal of luteinizing hormone, then they might not be producing as much testosterone. If they're producing insufficient testosterone, then you would have both lower sperm count and decreased negative feedback on GnRH and LH, and therefore you would explain all of the data, because you would have higher gonadotropin-releasing hormone and luteinizing hormone due to the lack of feedback. Option number 2, of course, is that there's some type of damage to the tissue. So it's not that they're not getting the receptor, but that the tissue simply is unable to produce the testosterone. If you come through and say, well, what's a possible reproductive therapy for Gennaro? In that case, you'd have to say, well, it would have to be some type of testosterone supplement. When we come to number 4, describe the data showing Leslie's hormone compared to the levels of normal women her age. And so looking at our 4-part graph here, the first one is GnRH. You see that both Leslie and the normal lines both look pretty much parallel, with a peak in gonadotropin-releasing hormone at day 14 of the cycle. When you take a look at follicle-stimulating hormone, you see the exact same pattern, although a little bit less peaked. If we then come through and take a look at luteinizing hormone, however, we see that luteinizing hormone for the normal line goes and again peaks at day 14 and then drops back down. In the case of Leslie, it does not peak at all. In the case of estrogen, what we might see is that you have a double peak, one at around day 10 and one at around day 21 for the normal line. But in the case of Leslie, you only see one peak around day 10 and no peak at day 21. So if we want to describe what type of cellular or molecular mechanism would explain Leslie's infertility, well, in that case, you say, well, we have to pick a location. Again, I would say it'd have to be somewhere in the anterior pituitary. The issue of the estrogen points somewhere to the ovaries, but it does produce estrogen for the first half of the month. However, in the case of the luteinizing hormone, that's simply not being produced. So one possible explanation is that the cells responsible in the anterior pituitary for producing luteinizing hormone simply are not functioning properly. This could be either due, from a molecular perspective, of a receptor error or some type of issue with the cellular production or protein trafficking of said luteinizing hormone. Suggest a possible reproductive therapy for Leslie. That would be a timed luteinizing hormone injection, coinciding with that portion of the month. So that's it. We have answers for group work 5, for homework 3. Stay tuned. Later tomorrow, we'll have another one of these videos that discusses group work 6. Make sure, again, to take another close look at these group works and the most recent homeworks, because you'll see similar types of questions when you come to the exam on Tuesday. But till then, stay healthy, stay safe, and I'll see you later.